Fine, let's start this. So yesterday we are discussing something called as shallow copy and deep copy, right? So let's try to understand that. Okay. So am I audible?
Yes, sir.
Okay, fine. So observe here, guys. So there are two types of copies in Python. One is shallow and one is deep. What does that mean? For example, see, observe, I'm creating a list over here. Okay, my list is L1. Okay, and I'm creating. Okay, first let me print L1 and I'm printing ID of L1. Okay, so this is a ID. Okay, so yesterday as discussed, what will happen in the memory location? It will consider one memory location which is ending with 56 and it will name it as L1 and it will put the value like 1, 2, 3, 4, 5. Okay, that is a thing which will happen in the background. Now, after that, what I'm going to do, I'm saying L2 equal to L1. So L1. Okay, now when I do this, for example, if I show here only, if I say L2 equal to L1, and if I print L2, okay. So if you see here, when I said L1 equal to this, L2 equal to L1, I'm printing this. So L2 equal to L1 means it will, I'm saying to use the same memory location. So L1 is pointing to this. Now L2 will also point to this. Okay. L2 will also point to this. So that's why you are having the memory location as same. Okay. So now if I change the value of some value L1 equal to L1 of 0 equal to 100. Okay. Now if I print L1 and L2. Okay. So can you observe here? I have changed only the value of L1. I did not touch L2. Agree? But when I changed only L1 of 0 equal to 100, that means only this value I changed. But when I'm printing L1 and L2, both are getting changed. Can you see? Why? Because this type of copy is called shallow copy. That means we are copying L2 from L1. But how we are copying? We are using the same memory location. Okay, we are using the same memory location. So if I do this, so if you see earlier, okay, yeah. So now if you see in this memory location, we are having 28. So earlier in this 28, we are having 1, 2, 3, 4, 5. Okay. So now if I'm changing this particular value to 100, okay, all the variables which are pointing to this memory location will get impacted. Okay. Now because L1 and L2 are pointed to the same memory location, even if you change this value for L1, L2 will also get impacted. Getting? Similarly, if I change the value of L2, see I'm changing the value of L2, 500, but did not touch L1. But still the L1 value will also change 500. Why? Because it's not about the value what you're assigning. So it's about the memory location. So whatever, if you're changing this memory location, so what all the variables, no matter how many variables are pointed to this memory location, all of them will get affected. L1, L2, even if it is 100 values also, everybody will get affected as long as they are pointing to this same memory location. Is it clear?
Yeah, Santosh.
Okay. So this is called shallow copy. That means what we are copying, but it is not a perfect copy. That means if you change the actual base variable, everything gets impacted. Okay. And also why this is happening? Because this is mutable. If you remember, list is a mutable. Okay. List is a mutable data type. Okay. And numpy array is also mutable. Okay. But in case of integer, so what happens when I do this? A new memory location will get created. A new memory location will get created. Okay. So I will show that, but don't get confused. Okay. So that's why I'm not showing. But for example, if you see, um, over here, if you see a simple example, L, I have created 1, 2. I'm printing L, ID of L. 1, 2, ID is 600. Okay, that means a memory location with 600 is now having value 1, 2. Now, when I'm changing L of 0 equal to 10, that means this one I'm changing to 10. Okay, so it is getting changed. Yes, 10 comma 2 it became, but where? In the same memory location. Now, this 1, 2 became 10, 2 in the same memory location. Why? Because list is a mutable. That means you can change. Once you create a value, okay, you can change the value in the same memory location. Okay, that is the meaning of mutable. But if I show you the example of another example of, let's say string is immutable, right? So when I say s equal to hello, okay, and if I print s, okay, and if I say print id of s, okay, now bolo, if I give bolo. Now if you see here, earlier s is having hello, okay, earlier some memory location what 56, okay, some 56 memory location is having hello, okay, that is yes. Now for this s earlier it is hello, but now it is bolo. So you are changing the new value of the value of s is changing, but that does not mean the memory location is getting changed, because when you say when you're assigning a new value, okay, when you're assigning a new value to s, okay, it will not change over here. It will go for a new memory location. That means instead of 56, you can see it is 76 now. Okay, some other memory location over there, it will be having bolo. Okay, but wherever the memory location is 56, still the hello will be present over there only. Still the memory location will be present there only. The value will be present there only. Why? Because string is a immutable. That means once you assign a particular memory location, okay, dedicate a particular memory location, so the value stays over there. If you try to assign new value, a new memory location will be assigned, but the old one will stay there only. Okay, how can I prove that? See, S I have created. Okay, when initially S is having hello, that memory location is 56. Now after that S equal to bolo I give. So that means what? When I'm giving a new value, this value will not be changed. It will stay here only. Okay, it will not edit here. It will create a new memory location called as 76. Okay, so that will be created, and this S will now point to this. Earlier S was pointing to this, but now S will stop pointing to this, but now start pointing to this. Okay, 76. But as I said, this hello will be present in 56 memory location only. How can I prove that? If at all I'm creating one more variable called as ss, okay, and I'm creating value hello. Okay, so when I create a value hello, and if I see the id, can you see it is the same id over here, 3256, 3256? That means what? Once you created this particular variable, because string is immutable, that means this never gets deleted as long as I don't stop this notebook running. Why? Because in the background, Python interpreter does all this job. Okay, so an immutable variable is created. That means an s is created, which is immutable. So this will stay forever. Same thing for integer. If I create a equal to 10, that stays forever. Okay, and even if you assign a new value to a, this will stay over here only, but a will be pointing to new. After 10 minutes, let's say I'm creating one more variable z equal to 10. Fine. So now it will not create a new memory location because 10 is already assigned, right? So it will point to the, first it will check if 10 is already present, it will point the z to the same memory location. Same thing. I've created first s, hello, 256 is there. Now I'm moving s to some other memory location. That's fine. But hello will stay there only in same 56 memory location, whatever you have created, right? Earlier, hello will stay there only. So if I'm creating new variable s is equal to hello again, it will not directly go and create new memory location. First, it will check in the Python interpreter will first check in the complete memory location whether there is already any memory location which is holding this variable called as hello. Sorry, not variable, value. Okay, it will check if any memory location is already holding this value called as hello. Yes, you are having 56. So then it will just point this SS to there. Okay, because why? Because if it is keep on creating new memory location and the old won't get deleted, then that will be complete waste of memory. Why? Because first of all, mutable means first once you create, you can't delete it. Fine. And again, if you are constantly creating new memory location for the same value, it is a waste of memory, right? So that's why if for the mutable, once you have created it, first it will check if the value is already present or not. If it is there, it will point to the same memory location. As you can see, 256. 256. Are you getting this or was it any confusion?
Yes, sir, understood.
Understood? Okay, great. So this is for the mutable. Okay, this is for the immutable. Sorry, immutable. You cannot change this. So that's why memory will be shared. Okay, shared in the sense, yeah, same. But now coming to our example, ours is a list. In the case of list is what is happening? Idea of initially when I created 1 2, you are having 600. When I'm changing from 1 2 to 10 2, same memory location is getting edited. Okay, because list is what? List is mutable. It's not immutable, mutable. That means what? You can change it. The value in the memory location can change any number of times. So that's why you're having 1 2. Okay, now the point here is when now once we understand this, let's come back. So I'm saying when a same memory location is being shared by L1 L2, okay, even if you change this value, both L1 and L2 will also get affected because both of them are pointing to the same memory location. Okay, when you call L1, this value will be retrieved. Okay, so this is a called as shallow copy. Okay, shallow copy means what? It is not a strong copy. Okay, so it will get affected. But how to avoid this? You have something called as dot copy. Okay, that means what? If I say L1, for example, I'm saying L3 equal to 11, 22, 33. Okay, now instead of just saying L4 equal to L3, but I'm saying dot copy. This will be a deep copy. So now if I say I'm printing L3, okay, I'm printing ID of L3, okay, now I'm printing L4, now I'm printing ID of L4. Okay, so as you can see, L3 11, 22, 33, the ID is 320. L4, the same value I'm copying, but when I say dot copy, it will create a separate memory location. As you can see, 112. Okay, earlier it was just assigning. Okay, when I say just L2 equal to L1, it will use the same memory location. The value will be same, but it is same memory location. Whatever be the memory location of L1, it will be the same. But when I say copy, that means I don't want a same memory location. I want to copy this, but in a separate memory location. It will take these values. Okay, so 320 was here for L3. So when I say dot copy, it will copy these values into some other memory location, same set of values. It is 112. So now only the values are copied. After that, L3 and L4 does not have any relation, any dependency, because once the memory locations are different, the whole story will be different. Okay, so now when I say, now if I change L3 of 0 equal to some 400, okay, now if I print all these values, okay, Okay, so as you can see, I'm changing L3 to 400. So earlier, what was the L3 ID? 320. So now also 320. But what is the value of L3 400? Okay, so it's changed. But what happened to L4? L4 is earlier it was present at level 22, 33, 112. Same thing. Now also it's present at level 22, 33, 112. Same thing. L4 is not at all affected. Why? Its memory location is different. How? We have done it with dot copy. So now we have remove the relationship between L3 and L4. There is no dependency. Now this is called deep copy. That means it's deep. It's copied forever. As long as you don't change L4, L4 will not be affected. Is it clear, guys? Everyone? Or any confusions?
Okay, Santosh. So mainly deep copy will be useful for mutable things, right?
No, not like that.
Because for immutable, like for strings or for remaining, automatically it will create new one, right? Anyway, new memory location like that, right?
For which one? Immutable?
Immutable, yeah.
No, for immutable, it will not create, right? Immutable, it will share the
Yeah,
memory.
for same value, it will use the same object.
Yes.
Yeah. Okay. Here for same value 2, it is creating new object, new memory location.
Yes.
To use dot copy. Okay.
But as you said, but let's check. But as you said, that's a good point. So if I say A equal to hello, okay, and I'm saying print of ID of A, okay, and I'm saying B equal to A dot copy. So when I say copy, right, actually whether it is immutable or mutable, it should create a separate location. But let's say, okay, so immutable data types are not having the method as copy.
Okay.
Okay. Why can you think of why it is not having? Because if you say copy, now it should create a new memory location. Okay.
Yes.
So then the memory sharing concept we will not achieve. Okay. That means what? So if you're having A equal to 10, okay, that means a memory location is assigned for 10. Now, so because this A is an integer which is immutable, now you cannot remove this, you cannot change this forever. Now again, if I'm saying B equal to A dot copy, okay, now B is also an integer. Now again for the same 10, I need to create one more new memory location with 10, which is B. And now because this B is also integer, now which is also again immutable, this will also stay forever. So like that, for the same value, so it will keep on creating
Memory locations will be more than in the case.
yes.
Okay.
So that's why they did not give this copy for immutable. But if it is a mutable, you have. Okay.
Okay.
Fine. So that's regarding the shallow copy and deep copy, guys. So now let's move on with the NumPy part. So same concept. Why I explained this is the same concept you can achieve in the np.array also. Fine. So as you can see, the copy equal to true means the same thing. So when I say copy equal to true means it will create a new memory location. Okay. So x equal to np dot okay, x equal to np dot array 1 2 3. So when you change the value of x equal to 0 to 100, okay. Now if your value, if y equal to x, now y of 0 will also be 100. Okay, the same concept which I've explained over here. So now when you're saying y equal to x, just when you say y equal to x, some memory location will be shared. When you change the value of x, to also change the value of y. Okay, but in order to avoid that, you can say np dot copy of x. Okay, now z equal to not just x, but np dot copy of x. So in that case, when you change the value of, in that case, when you change the value of z, okay, so it will not affect the x. So see, so I'm changing the value of z equal to 500. So only z will get impacted, but x will not be impacted. Okay. So the same concept which you have studied earlier. Fine. So after that, let's move on. Are we good, guys? Are we good? Did you understand this part? The copy part from the NumPy.
Yes, sir.
Okay, fine. So after that, we have like small functions. We will try to understand. See, we have from NP NumPy from function. Okay, what does it do? Simple. So it is saying from lambda also we can create a array. So how we are creating? We are saying take two I comma j where I equal to j. Okay, so no, we are checking I equal to j. That means what? See, what are these guys? These are rows. These are columns. Okay, so what is this 0, 1, 2, and this will also be 0, 1, 2. Okay, so now when he's saying I is row j column and he's saying whether I equal to j, that means whether row equal to column, when in which place it will be equal in the diagonal, because this is 0 comma 0. Okay, this is 0 comma 1 like that. So when this will be I equal to j, when this row and column will be equal, over here 0 0, over here 1 comma 1, and over here 2 comma 2. Okay, only the diagonal part you will have I equal to j. Okay, so that's why you can see diagonal part it is true, true, true. Apart from that, everything is false. Okay, he's checking that way. I equal to j. So here it is false because it is 0 is not equal to 1. 0 is not equal to 2 like that. But in the diagonal part, yes, 0 equal to 0, 1 equal to 1, 2 equal to 2. Clear? Okay. I hope that's clear. Okay, fine. So I will keep on going, guys. So wherever if you're not understanding, right? So you can just stop me over there. Okay. So if you don't stop, I'll assume that we are understanding. Fine. Fine. So np dot from function, here we are saying that create 3 by 3 matrix. Earlier also we are saying 3 by 3 matrix. Okay, in 3 by 3 matrix, wherever you are having I equal to, check I equal to z. So if it is equal to yes, then true, or else it's false. Okay, so now again create a 3 by 3 matrix, but just multiply the values of I and j. So what are I and j, guys? As I said, 0 1 2. So here you will have here it will be 0 1 2. Here also you will have 0 1 2. Just multiply these values. Okay, 0 0 0 0 0 0, 1 into 1 1, 1 into 2 2, 2 into 1 1, 2 to the 4. Okay, so that's how you are creating. So how 3 by 3 matrix I into j. Okay, so like that you can create any number of values. So I into 2 you can say, or I into 20 you can say, any number of values you can just create from the given values only without assigning any new values. From the I and j values only you can start creating. Okay, fine. So after that, from the iterable also you can you have seen generator concept. Okay, so how you can create a generator. So for x equal to I in range of 5, x into x. So that means you are squaring the number till the range of 5. 5 means it will take 0 to 4. Okay, so 0 to 4 square numbers it is creating in the iterable. This is generator. Okay, so if you put this in this way, square bracket, that will become a list comprehension. But when you put it in the curly braces, not curly, what is just braces, it will become generator object. Okay, from this generator object also now we have iterable. So you can also create an array. How? np dot from iter. Okay, all these are functions. If you observe, from function, from iter. Okay, these are functions in the library numpy. So from iter, inside this, if you just pass iterator, so it will, and if you say float, okay, so it will create an array. Okay, these are different forms of creating array. Fine. So from string also you can create. So this is a string. Okay, and I'm passing a string in this way, and I'm saying separator equal to space. Okay, so wherever you're having a space over here, so that create that as separator. That means that will be a separate string, and create a new form of array. So as you can see, array of 234 234. Okay, so over there you have a space over here, so it will consider before space as one string and after space as another string. Okay, so but if you don't want the space as separator, separator as a space, you can also give it as a comma. So over here I'm saying 1 comma 2, so it will consider 1 as separate element and 2 as separate element. Okay, simple. So after that we have something called as np dot array, the class. Okay, so how do you find out the type? So data type, so same thing we have discussed in the initial. To find out the data type, just say type of ARR, you get numpy.ndRA. Okay, so after that we have size, dimensions. Okay, so this I have explained in the yesterday's class itself. Okay, so you have dimension, you have size, you have shape, you have data type. Okay, so you will get name, size, shape, data type. Okay, so we have shown the I've shown different examples also. What is size, number of elements, shape, rows by columns, and dimensions is how many dimensions you would like to want. Okay, so then what? Okay, you can also convert the change the data type of the modified matrix. Okay, so np dot array. So give if this given the matrix. Okay, so this matrix, if you want to convert it into data array, so just say np dot array. Okay, and over there, if you say matrix dot data type, it will get what is the data type of all the elements over here. So as you can see, one of them is float, so that all other will also be converted into float. Okay, because the array are homogeneous, which you have seen yesterday. Okay, so from the tuples also you can create. Okay, that's fine. These are simple. Next important concept is actually arrange and line space, Okay, this is important. Okay, this is a bit tricky. Okay, but let's try to understand. Okay, see guys, you have range function in Python. Okay, for I in range of 5, like that. Okay, in NumPy array, you don't have range. Okay, you have a range. Okay, you have a range, and something similar to a range is linspace. Okay, so these two are important. See guys, when I say a range, input a range of 5, 16, okay, 2.3. Okay, so first of all, let's take a simple example. Okay, so see, when I say a range, it is similar to range function in Python. So what's happening? 5 to 6, start from 5, go till 16 minus 1, 15 at a step of 1 each. So 5, 6, 7. Okay. So if I do it at a step level, okay. So if I do it at a step level of 2, what happens at a step level? 5, 7, 9, okay, till 15. Okay. So it will take a step of 2 every time. The difference between any two elements will be same. Okay, same thing over here. 5, 16, 2.3 when I say, so it will take a step of 2.3 every time. So 7.3 minus 5 will be 2.3 and 9.6 minus 7.3 will be 2.3. So it will take a step of 2.3 each time. Okay, that is a range. Okay, but now there is something called as, okay, there is something called as linspace. Okay, first let's do I'll show you linspace, because yeah, coming to arrange, so same thing you have guys. So what all the range functions you can do over in the Python, like same thing you can also do here. That means what? So I can say 50 to minus 1, 5, right? So that means what? Start at 50, okay, go to minus 1, but with a positive step of 5. Positive step of 5. Can I reach minus 1? No, I cannot reach. That's why I'm getting empty array. Understanding? You remember negative indexing in strings we have seen. Okay, so when I say minus 5, you will get some values. That means why? Because I'm saying start at 50, reach minus 1, but in the negative direction, minus 5 in negative direction at a step of 5. That means 50, 45, 40, 35, 30, like that. Go till end minus 1, minus 1 step below this. That means 0 till here. Okay, so do you remember guys? Are you able to recollect this?
Yes, Santosh.
Yes, sir.
Okay, fine. So the same thing you can also do it in the NumPy arrow, but just you need to use np.arange, okay, instead of range. Okay, that is exactly the same. But there is also some other thing called as linspace. Okay, this is what. So when see here, when I'm saying 1 to 5, 50, okay, what we'll do here is observe here, 1 to 5, 50 means it will divide the space between 1 to 5 into 50 parts. 50 equal parts it will divide. Okay, which is different from a range. A range means what? When I say a range 1, 5, 50, range function will do what? 1 from 1. This is step function in the range. Agree? So from 1, it will take 50 steps at a time. 50 steps at a time till this value. Or this value minus 1. Okay. But in linspace, it will divide the given values, the space between these values into this many number of parts. Okay, over here it is parts. In linspace, this is parts. Okay, divide 1 to 5 into 50 parts. So see, these are the 50 parts. So what is each part? 1, 1.0, 1.5. So all these are 50 parts, 50 equal parts it is creating. It is dividing the given value range 1 to 5. But a range function will do what? It will try to take a step of 50 each time from the starting to reach the end value. So are you able to understand the difference?
Yes.
Yes. So Sirisha, you said yes.
Yes, sir.
Okay. So now for the same value, if I just take range, so can you guess what I will get? Not only Sirisha, anyone. Can you just guess if I give np.a range 1 to 50, 1 to 550, what will be the answer?
Only one. Four.
Hmm?
One.
Good. Excellent. So it's 1. Because why? Because you are starting at y 1 and you need to take a step of 50. So obviously you are reaching this you are like by overpassing this 5. So you don't have any values to pick up. So it is only 1. Super. So what if I give just 500, Meghna?
150, 100.
Correct. 150, 100. So it will add 1 to 50, right? 1 plus 50, 51. Okay. So that's perfect. So that is a difference. So if you see, guys, so for example, if I will show you with the same example so that you can understand. So I'm giving same, see, 1 550 I'm saying. Here also I'm saying 1 550. Okay. So but what's happening over here and what's happening over here, you see. Clearly you can see when I'm saying a range 1 550, that means what? This 50 over here is what? Is a step. That means what? I'm saying, hey, start at 1, take a step of 50 at each time. Okay. So whether you are going to reach this 500, I don't know. Okay. Usually it will be 500 minus 1, right? So whatever the value you are taking, that value minus 1. Fine. So just start with 1 and go till 50. And wherever you are able to reach this 500 minus 1, if you stop there. Okay. So 151, 101, like that. And what will be the till what value I should consider? 500 minus 1, 499. 499 I should is what I should consider. But after reaching 451, what is the step value? My step value is 50. So if I add 50, how much it will be? 501. So 501 is greater than 499. So I will not take 501. I will stop here. Okay. So that's why it is taking 1. It is taking a step of 50, 151. Okay. The step is 50. But over here, if you see, I'm saying from 1 to 500. Okay. So that means definitely it will consider 1 to 500. So you can also see 1, you can also see 500. So that's the difference. You can also see 1, you can also see 500. Now this range from number 1 to number 500, this range, this space divided into 50 equal parts. Okay. So this is a part. So 1 to 11, 21, 31, 41. So like that, it is dividing it into 50 parts. Okay. This 50 is a part. Okay. But here it is, you'll not get here 50 parts. Okay. So here the step will be 50, but the value between each and every two, the difference between each and every two values will be 50, because that is step value. But you will have small steps. So, I mean the less number of values, because the value is difference is 50. But here total the number of values you are getting here will be 50. Okay, the total number of values you are going to get is 50, because the number of 50 parts we are dividing, but the difference between each and every value will be very less. The difference you don't know. Here what 11 is the difference. Okay, getting, guys? Everyone, any confusions? So I'll show you one more example. So for example, if you see here, See, what is A range doing? 124. That means what? Start at 1, end till 20 minus 1, 19. So from 1 to 19, take a step of 4 at each time. 1 plus 4, 5, 4 plus 5, 9, 9 plus 4, 13, 13 plus 4, 17, 17 plus 4, 21. So, but I should stop at 19. So I'll stop here. That's a simple range function in Python also. So that is range. Okay. Take a step of 4. But here the same 124 in line space, that means what? From 1 to 20, first it will consider in line space, you can clearly see starting value, whatever given you are giving, and end value also you can see in the output. So here also 1 to 500 means 1 also you can see, 500 also you can see. But in the A range, you cannot see the end value because it will consider n minus 1. So you cannot see the end value anytime. Okay, here also you cannot see the end value, 20 you cannot see. But in line space, 1 to 20 means it will consider 1 to 20. This space between this divided into 4 equal parts. Okay, 1, 2, see 1, 2, 3, 4. Okay. Is that clear, guys?
Yeah, Santosh. So 1 to 20, 4 equal parts. I mean, I'm guessing like why it is differencing like 1 and 7.3. 4 equal parts, 1 to 20 means like 1, 5, 15, 20.
4 values you will be see. 4 equal parts might not be correct, but 4 in the output you should see 4 values.
Okay,
So
whatever
1
the
is one value,
difference.
7 is one value, 13 is one value, 20 is one value.
Okay.
Right? So for example, if I say, yeah, I got your point. So for example, you say 1 to 30, okay, 6 parts means overall in the output you will see 6 values. So 1, 2, 3, 4, 5, 6. So in that case, how many values? 6 minus 1, 5. 1, 2, 3, 4, 5. Okay, so 6 values you will be seeing in the output. So in other words, it is creating into what? 6 minus 1, 5 equal parts. Okay. Okay, so here also if I say 5 equal parts, you will get what you have said as 1, 5.5, 10, 15.5.
Okay.
Okay, fine. So that is okay. So, but be clear with the difference between A range and line space, guys. This looks similar, but it will be different. Okay, fine. So after that, we have matrix creation part. So which is which we have already covered most of this in the linear algebra session. Okay, but just I'll give you a walkthrough. NP dot zeros. Okay, create zeros with just 5 rows. Okay, so just 5 columns. Okay, and after that NP dot 0, 3, 4. That means 3 rows, 4 columns. Okay, NP dot ones, same thing. Create 5 ones. NP dot ones 5 to 8. That means 5 into 2 into 8. That means overall set of 5. Inside 5 for each value 2, 8. That means 2 rows, 8 columns. Okay, simple. And 5 plus NP dot 1 of 3, 5. So NP dot 1's 3, 5 means it will create a 3 by 5 matrix with all values of 1. To that we are adding 5. So it will become all 6. So the dimension, the shape will be 3 by 5, but the value will be 6 because we are adding 5. Okay, just a scalar addition.
Yeah, Santosh, can you please go? Yeah, why it is taking 3-dimensional in the 1, 1, 1, 1.
This one here,
Above.
the here,
All ones. Yeah.
here,
Okay, 5 to 2, yeah.
where it is 3 dimensional, it's a 5 dimensional. Right?
5.
See, overall 1, 2, 3, 4, 5 you are having it.
Yes.
This 5 is create set of 5. Inside each set, the dimension should be 2. Number of rows is 2 and 8. 2 rows.
8 columns.
1, 2, 3, 4, 5, 6, 7, 8 columns.
Okay, what about this braces? I'm little bit confused that in the top I can see 2 braces or 3 braces. For
Okay.
remaining ones I can see 2.
See,
Yeah.
these are okay, I got it. So see, these are the, this is just what? This is 3 dimension. This is not the dimension. Okay, so I understood your confusion. See, when I say See, the 5 is not the dimension, Karthik. Okay, so I will show
Yeah.
you. When I say size, see, dimensions is what? 3 dimension. Okay, 1, 2,
Mhm.
3 dimension. Okay, that is 3. Size is 80. Okay, why? All this 3, 5, 5 to the 10, 10, 80. The multiplication of all this. Okay, total elements, 80 elements are there. And shape is 5 to 8. Okay, so 5 to 8 means what? Rows, columns, like this rows and columns, how many times I should report? That is 5. Okay, this 5 is not the 5 dimension. If you
Yes.
want to create a dimension, okay, if you want to create a dimension, so
So white is taking only 3 in this case.
which
mean,
one? 3? This
3
3?
dimension. Yeah.
Because how many, see, these are, each one is a dimension over here. 5
Okay.
is one
Okay.
dimension, 2 is one dimension, 8 is one dimension. What is 2?
Mhm.
This is rows. Row is one
Row.
dimension. What is x? See, xy in xy space in what do you say, in trigonometry, when you in the graph, this is origin, this is x, this is y. Agree?
Yeah.
What is x?
Yes.
X is one dimension. What is y? Y is one more dimension. If you have 3D, what is this? Z is one more dimension.
Correct.
Correct. Here also, these are not values. These are not values. These are dimensions. Why? Because one. Okay, I understood your confusion now. See, I am not creating a array with values. Okay, so okay, this is np dot 1. That means all the values inside this matrix will be ones.
Yes.
Okay, but when I say np dot array, okay, when I give 1, 2, 3, that is different. Here I am creating an array with values of 1, 2, 3 or some 10, 10, 2, 3, etc. Okay, the values which I'm giving over here are the actual values I want to be present in this array.
Okay.
Okay,
Yes.
that is correct. But when I'm saying np dot 1, I don't need to give any values, because when I say 1, that means all the values inside the matrix will be obviously 1.
Yes.
Okay, you cannot have other values inside np dot ones. Okay, so but I just need to specify the dimension, what type of dimensions I should create, but the values will be always 1.
Okay.
No, tell me if it's not clear. So this is dimension, but here
Yes.
here see, there's a difference. When you're creating np dot array, based upon the values only, the dimension automatically will be decided. Okay, when I'm saying 10, 23, again I'm saying 11, 22, 44. Okay, field must be 2 or 3 tuples. Got 22. What does this mean? Field elements must be 2 or 3 tuples. Just give me a second. The way how we operate. Okay, so here when you say 1, 2 and 3, 4, fine. Based upon the values you are creating, only the dimension will be decided. Okay, so when I see this as some a equal to this, okay, and when I print a, okay, so here am I giving any dimension? I'm not saying any dimension, but still if I print a dot n dimension, it is creating 2. Agree? It is having rows and columns. That's all it is having. Okay, and when I say a dot shape, it will say 2, 2. Okay, 2 rows, 2 columns. But ultimately it is having rows and columns. That's it. X and Y. That's it. Rows is one dimension. columns is one more dimension. That's just 2 dimensions. That's why n dimensions is 2. Okay, that means what? 2 means what? 1 row, 1 column. But how many rows you are having, how many columns you are having, that you will know from the shape.
Okay.
Okay.
So can we create some like same array with 3 dimension?
Over here, yeah, that you can do. Yesterday we have seen, right? So if you want to create one more dimension, see, I'll show you 2 ways. So okay, now but this is also a what now what is that became 3, 2, 3 rows, sorry, 3, yeah, 3 rows, 2 columns. Okay,
But
so
dimension is 2 by 2 only. I mean 2 dimension only.
2 dimension only.
Yeah.
Okay.
Okay.
But if you want to create more dimensions, okay, so if you are creating this, what is happening? You are creating one more set of rows. That means 3 rows,
Yes.
it became 2 columns, but the dimension is 2. But if you want to create more dimensions, yesterday I have shown that n dimensions, if you give 5, okay, what is the parameter? I forgot. So here in, yeah, nd min, okay,
ND equal to.
nd n dimension. Okay, so if I give 5, see now if you check the dimension, it is 5.
Yeah, based on braces we can
Yeah.
we
So and
can
if you see the shape, it is just 1 1 1 3 2. Okay.
yeah,
The
remaining all
actual
are
thing,
ones.
yeah, the actual thing over here, the value which you're seeing over here, that is having 3 rows, 2 columns, that is 3 2. But when you say dimension is equal to 5, so it will just add 1 for each. Okay, so this is the dimensions. Here we are creating a dimension specifically, but if you don't want directly, it will take the dimensions from the value whatever you are giving.
Okay.
Okay, so from the values whatever you're giving, it will create the dimension. Okay, but over here from np.ones, you should tell the dimension, because you don't need to tell the value. Value will always be 1, but only thing you need to tell is the dimension. Okay, so here you are saying 5 to 8. Now 5 to 8 is what? Each value over here is 1 dimension. Okay, 5 is total set of, like that I want 5 values. Inside that each set you should have 2 rows and 8 columns, is what we are saying. So dimension is 3 dimension. This is 1 dimension, this is 1 dimension, this is 1 dimension, total 3 dimensions. Dimension is 3. Okay, but the actual one will be the last 2. So for simplicity, just understand the last 2, how many dimensions we are having, the last 2 will be the rows and columns. The actual value which you are holding, right, that will be the last 2. Okay, it should have 2 rows, 8 columns. Okay, like that you should have 5.
Okay.
So you can see that when you're having 2 rows got created, 1 dimension got created, 8 columns, 1 more dimension got created. Like that, this is getting now expanded in another direction.
Yes.
5 set of 5. So one set is created, and the same set is now expanding into in another direction, this direction. So it became 1 more dimension, right? 5 to 8. So that is 3. See,
Yes.
when I say 2 5 to 8, okay, when I say 2 5 to 8, now see, if I just show you 2 5 to 8, it is 4 dimension.
Yes.
Okay, that what now 4 dimension, and inside that shape is 2 5 to 8. That means what? Ultimately, as I said, the last 2 will be the rows and columns. The last 2 will be the rows and columns. Okay, just that means what? The actual thing what is holding the values are 2 and 8. That means 2 rows, 8 columns is same. That is clear. But now you are having 2 and 5. That means this 2 comma 8, the item set which is having, right, this particular value, that you should repeat 5 times. 1 2 3 4 5 repeated, like in the previous case. 5 times repeated, done. But that 5 time what you are repeating, that this whole set, now this, see guys, I'll tell you.
Oh, this whole set again repeated
2 times
twice.
Correct. Okay, now 2 comma 8, just this, only this particular part is what size of 2 comma 8. Agree?
Yes.
Okay, now this 2 comma 8 I should repeat 5 times. That means this is 1 2 3 4 5. That means this became 2 by 8, 2 by 8. Now this became what? 5 by 2 by 8.
Yes.
Okay, 5 by 2 by 8. That means 5 times it is repeating. What it is repeating? 2 by 8 set is repeating. Inside this, each of this is 2. Okay, that became 5 to 8. Clear? Now this 2 5 to 8 means what? This, whatever this 5 it is
Set.
repeating, that I should repeat 2 times.
Okay.
Okay, this is one time, this is 1 time, this is same set another 1 time. Now this will
Okay.
become 2, 5, 2, 8. Okay, is that clear?
Okay. Yes.
Others?
Yes, sir.
Clear, right? Yeah. So same thing. So if I give 3 here, it will just keep on creating it. See, 2, 8 you should create like that. 5 sets you should create. Okay, this 5 set, this like this 5 set you should create 2 times. Okay, 2 times, and this 2 times you should the overall like that you should create 3 times. So it is just a loop, you see. Okay, just looping inside that. Okay, fine. So I hope that's clear. So after that what we have is called as, is it clear? Yes, Sirisha, did you follow?
Yes, sir.
Okay, fine. So let's quickly see. So again, you have something called as np.empty. Okay, so just like how you have empty.1, empty.0, you have empty.empty. But the one thing is regarding empty is empty matrix will never be empty. Okay, so always it will have some random junk value. Okay, don't expect it should be empty. So see, in np.empty, I'm saying 3 by 3. So you can see some value over here, some value, exponential value, some other value. Okay, so every time it will create some value. Okay, so see, some value you will get, but don't be confused. What are these values? These are some just some random values. Okay, so but it isn't, but you cannot access those values. It is just, it cannot create an empty matrix. It will just create some random junk values. Okay, fine. So after that, what do you have is np.I. What is I? Identity matrix. What is identity matrix? All the values in the diagonal matrix will be 1. Okay, these are 1. So that is called identity matrix. And what is the shape? This is 4. That means 4 by 4. Okay, see, Karthik, you observe, like whenever you are having a specific np.I or 1 or 0, fine, you don't need, you don't need to give the values, you just give the dimension. Why? This will only, these are specifically telling about the values. I means diagonals will always be 1. 1 means all 1s, 0 means all 0. So the values you are specifying over here only. The only thing you need to give is dimension. Dimension. Agree? And also over here in the 1, you can give dimension as anything. 3, 4 also you can create. 0, 0 also you can give any 2, 4, 2, 5, any type of dimension you can create. Okay, but coming to I, what is I? I is an identity matrix, and identity matrix is a square matrix. Square matrix. That means what? Number of rows will be equal to number of columns. So that's why you don't need to give 2 values. You can give any one value. Even if you say 3, that means 3 into 3. If you say 4, that means 4 into 4. Why? Identity matrix is a square matrix. Okay, so that's why if you see np.I, I just said 4. I did not say 4, 4, but still you will understand because it is a square matrix. So it will create a 4 by 4 matrix. Okay, you can say this is a 4 by 4 matrix, and it is an identity. That means diagonal values it will put all as 1. As 1. Is it clear?
Yes, Santosh.
Clear, perfect. So after that, the same thing, np.range we have seen, np.arange we have seen, arange, the same. I'm not going into these details. Okay, 3, 7, 2 step. Okay, and np.line space also you can give. Okay, so you can also specify the number of values you want to see, number equal to 5, and see, if you say endpoint equal to false, that means it will not consider this endpoint as 3, it will not consider. Okay, so that means what? It will not show the 3 over here. So if I'm running this, okay, so from 2 to 3, but endpoint is false, means it will not show the 3 over here. But if it is true, it will also consider the endpoint as 3. Okay, and you have return step value. So return step value means it will also from 2 to 3 divide it into 9 parts and also return the step value. Okay, so it is also returning. So this is from 2 to 3, these are the 9 parts, but step value is this 0.125. It is dividing. Okay, it is one more parameter. Okay, fine. np.arange you can also reshape. Okay, that's completely fine. And after that, yesterday in the linear algebra session, if you remember, we have seen something called as k value. Okay, so if you have this value, the diagonal part will be 0, k equal to 0. The above one will be k equal to 1. This will be k equal to 2. The below will be k equal to -1. Do you remember?
Yes, sir.
Okay, same thing. So this is our matrix. Okay, this is a diagonal np dot diagonal matrix. Np dot diag. See, when I'm saying np dot diag of x, that means take diagonal diagonal values from this matrix. What are diagonal values? 0, 5, 10, 15. So you got 0, 5, 10, 15. Okay, but I'm saying take diagonal, but at k equal to 2. Okay, this will be 0. Above this will be 1. Okay, and this will be 2, and this will be 3. What is 2? 2, 7. 2, 7. Okay, and what is this? This will be -1. And what is this? This is -2. Okay, so when you say -1, it is 4, 9, 14. Getting? Are you able to correlate? Above will be 0, 1, 2. Below will be -1, -2, -3. Okay, simple. Fine. The same thing applies for all this. Okay, so and there is one simple but beautiful function in NumPy called as ravel. Okay, when you say ravel, it will just extract all the values inside from all the list, whatever the list you are giving, right? So it will just extract the values from that and it will give you it in a simple list. Okay, it will just unravel that. Okay, so if you say 5, 6, so
Remove that extra brace from after 4, 3, 4. I mean, you have to.
oh, okay.
Yeah.
Okay, so it will just extract all the values. Okay, and what is this? Diagonal dot flat 1, 2, 3, 4. Okay, so it will flat 1, 2 -1. Okay, you have there will be three things over here. So one will the diagonal dot flat, and one thing will the np dot tri. Okay, which will create triangle, and one is triangle lower and one will be the triangle upper. Okay, so I'll just see whether we have the time. So next we have the something called as random generation, and when we have the next thing we have something called as reshaping. Okay, so after that you have indexing, then you have subsetting, slicing, universal function, and broadcasting, and some array math. Okay, so fine guys, I think we can cover this tomorrow. So mostly we can cover conclude NumPy tomorrow. So I'll see if there are any other functions missing, so I'll try to include that also. Okay, so I would say we can like stop the class over here. So at the ravel, right? So just put the story. Okay, so fine. So as I said, NumPy, see all these are you are learning, right? If you're having the question that where are we going to use all these functions? So as I said, so there is no guarantee that you are going to use every function we are learning this. Okay, but it is, since you're learning NumPy, right? So you should be aware of all the different functions. Okay, so that's a idea over here. Okay, but I don't think there is any difficulty in learning any of these functions. Right? Very simple, straightforward functions over here. Okay. Yeah, I would say that's all, guys. Okay, so tomorrow we'll see if we can conclude the NumPy part, and yeah, so that's, so I hope everybody got the link mail, right? Documents, notebooks, Excel sheets, OneNote, right? And did anyone try to open the OneNote and see if you're able to see same as mine?
I didn't try, Santosh. I will check.
Okay. No one tried. Okay, fine. Check it, guys. Check if you're able to get the same. I think it will be in sync. Every day I update something over here, right? So you can see the changes over there. So I think that should be the way. But just check and let me know if you're having any issues. Okay. Fine, guys. That's all from my end today. Okay. Take care. Bye. Let's meet tomorrow.